Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting video, guys, that I'm very excited about. So let's go ahead and read the problem statement. So yeah, guys, the problem is called binary tree maximum path sum, right? So it says a path, right, in a binary tree, right, is a sequence of nodes where each pair of adjacent nodes in the sequence, right, has an edge connecting them, right? It says a node can only appear in the sequence at most once, right? It says note that the path does not need to pass through the root. I'm saying it also says that the path sum of a path, right, is the sum of the nodes values in the path, right? It says given the root of a binary tree, return the maximum path of any path, right? So this problem is very good, guys. So pretty much what they said in this whole text, right? Pretty much, so now this question kind of resembles some of the problems we did in the past, right? We did path sum 1 and path sum 2, right? With those problems, guys, we were bounded to only considering path starting from the root to a leaf node, what I'm saying. So this one is a little bit different. We could, we don't have to, it's not only from the root to leaf path that we're considering, right? It says the path may or may not pass through the root, what I'm saying. So that's the thing that we're considering, what I'm saying. So 1 and 2 is a path, right? 1 and 3 is a path. Also 2, 1 and 3 is also a path, what I'm saying. So that's why it makes this problem interesting, guys, what I'm saying. So this problem is kind of similar to a problem that we did earlier, guys, I'm saying. It's called the diameter of a binary tree, I'm saying. Pretty much it's going to be kind of the same logic, right? I'm saying it said the path may not pass from the root, may or may not pass from the root through the root, I meant to say, right? So that's kind of similar thing that you said in diameter, I'm saying. So now the same thing on diameter, right? We consider path that went like this one, those kind of weird paths, what I'm saying. So it's kind of, that's why the solution guide, the implementation now we're going to do is going to be extremely similar as well, I'm saying. So if you guys haven't done that problem before, or haven't seen this problem before, I highly suggest you guys go check it out, because it's going to give you a lot more context and help you guys understand this problem a lot better, I'm saying. So now, guys, they got 6, right, because they considered that path, right? So how they got, so yeah, so let's do this one real quickly, right? So now this one is same thing, right? The path that they're considering is 15, 20, and 7, because that's the longest path, right? We could try any path, right? Negative, so this path, right, is not the biggest one. This path is not the biggest one, right? So 9, negative 10, right, is I'm saying is negative 1 plus 20 plus 15, right? It's not bigger than 20, 15, and 7, which is 42, I'm saying. That's why. So how we're going to go about solving this problem, guys, is going to be very intuitive, right? So we're going to pretty much, have an instance variable, right, that's going to help us in keeping track of the global maximum path that we've seen, right? Kind of similar to that diameter thing that we did, I'm saying. So we have the instance variable, guys, I'm saying. So as we visit the nodes, guys, we're going to compute the local max for every node, I'm saying, the local max, right? And then every time and if it's bigger, if the local max that we got, right, is bigger than the global max that we've seen so far, right, then we update that global max to equal to that local max, what I'm saying. So let's go through a couple examples real quick. I think it'll make a lot more sense, right? So we start off at the root, right? The root goes left, right? So now once we go to 2, and 1's like, all right, 2, give me your maximum path, right? The maximum sum, I'm saying, path sum from your side, I'm saying. So 2 goes left, 0. 2 goes right, 0, right? So 2 got no choice but to return only itself, right? So 2 returns 2 to 1, right? So 1 got an answer from the left side. So now we go to the right, right? And then 3 does the same thing, right? 3 returns 3 to 1, right? So now 1 is going to make a decision, right? So when we, all right. When we were at 2, right, the global max was 2, right? And then we went to the right, right? The global max got updated to 3 because 3 is bigger than 2, I'm saying. And then now we're at 1, right? So now 1 is going to make a couple of decisions, guys, I'm saying. So 1 got an answer from the left side, right? Got an answer from the right, and then it says, all right, cool, which one's it's gonna be more beneficial, I'm saying. So he checks 1 plus 2 is 3, 1 plus 3 is 4, right? So he's like, So now so now guys, the thing that we're gonna do, right? So we also need to consider this other path, guys. I'm saying that I told you guys, is we're also gonna consider path like this, right? So how we're going to do it, we get the left side plus the right side, right, plus the node itself, what I'm saying. And then we check if that's a bigger, that's the local max, right? So I told you guys we compute the local max for every node, what I'm saying. So we do 2 plus 1 is 3 plus 3 is 6, right? So that's why we update the global max, right, to equal to that solution, what I'm saying. Yeah, so that's why we consider that. So let's do this example real quick, right? So -10, right? -10 goes to the left side, guys. Know what I'm saying? So he's like, all right, cool. 9, let me know your maximum path, right? From your side, I'm saying. So 9 returns 9, right? And then now 10 is all right, cool. I'm gonna check my right side now. So now I say 20, let me know what's going on. I'm saying. So 20, check its left side. I'm saying. So 15 returns 15 from the left side, right? So 20 knows that 15 is the maximum amount. So now it goes to the right, and then he's like, all right, cool. I got 7. So I check myself, 20 plus 15 or 20 plus 7, right? Which one do I need to return to -10, right? So obviously I'm gonna return 15, right? So 35 is bigger than 27, so I'll return 35 to the car, right? But before we do that, guys, we also compute the local, path, right? The local maximum path, right? So we do, we get the thing from the left side, which is 15, and the thing from the right side, which is 7, guys. What I'm saying. So we do 20 plus 15 is 35, plus 7 is 42. So the global maximum path summary, we get updated, guys, to 42, right? And then we will still return, yeah. So we update that variable, and then we return, obviously, the bigger out, either it's 15 or 17, we return 35, we return 35 to -10, right? And still, once we're at -10, it doesn't really help, what I'm saying, because we got negative, so we did 35 minus 10 is 25, what I'm saying, plus 9 is 34, I'm saying, which is not big, what I'm saying. So let's say, let's say this one, right? Let's say this path, right, was like, instead of -10, right? Let me up this one. So let's say, so you get a tree visualizer real quick. So, sorry guys. So right now, so yeah, so this is the same example, right? So now instead of having, let's say we had like a -1, right? We had a -1 up there, right? Now it will be a different story now. So the maximum path, right, will be this path, right? I'm saying that would be from 9, -1, 20, 15, right? That path will be the maximum path that we would get, right? I'm saying, because we do 9 minus 1, right, is obviously 8, right? 8 plus 20, which is 28. 28 plus 15 is 43, right? So that's why, which is bigger than 20 plus 15 plus 7, what I'm saying. So why we return, yeah, that's why we return the bigger one out of the two, right? That's how we construct the path, what I'm saying. We construct the path by choosing the maximum out of the left and the right, plus the node itself, right? And we return that up, the recursive calls, right? I'm saying. So that's why we do that, what I'm saying, because the path can be all of those things. So hopefully you guys were able to get the thought process and the logic, guys. So right now I'm going to be going with the implementation, what I'm saying. So guys, like I said, guys, we're gonna have an instance variable that's gonna keep track of the, so let's call it global max, right? And then that's an instance variable, I'm saying. So then we do global max, right? It's gonna equal to integer that min value, I'm saying. So pretty much equals a very, very small number, I'm saying, because I believe that the those values can be negative as well. So this will handle that case, what I'm saying. So now we're going to be using a helper function, guys, because we always use a helper function on problems, guys, most of the time when we're doing that first search problem, I'm saying. So that's why we use that, right? So we pass in the root, right? And at the end of this recursive calls, guys, we promise them that we're going to have the global max, right? And in this variable, I'm saying. So now let's go ahead with the implementation of the function, I'm saying. So we gonna be passing in the root, right? And we check, guys, if the root, right, the root equals null, right, we return 0, I'm saying. All right, so return 0. So now the next thing that we're gonna do, guys, I'm saying, we're gonna be going to the left, right? I'm saying. So now this is the interesting part about it, guys. I'm saying. So I'm going to be using 0, right, and helper root that left, right. So guys, I use a 0, guys, because if the value, the path sum, right, from the left side happens to be a negative value, right, then I'm not going to consider it, what I'm saying, because I'm only considering positive values, because that's what's going to help me in having the maximum sum as possible, I'm saying. So if it's negative, it's only gonna make it go down, I'm saying. So we ignore all the negative energy, guys, I'm saying. All the negative values, we ignore them. We're only considering positive values, I'm saying. Because that's what's gonna help us in having the maximum possible values possible, I'm saying. Because a negative value, no matter what number I am, it's gonna make me be even more negative, I'm saying. Yeah. So we do the same thing for the right, what I'm saying. So we ignore the negative values, right? So we choose that max between 0 or the answer that we're gonna get from the right side, guys, what I'm saying. And then guys, you know, what we're gonna do, guys, remember, right? We're gonna compute the local or the global max, right? The global max is equal, I can't type, to map that max, right? Which is the current global max that I have, right? The current global max, or the left plus the right plus, remember what I talked about, right? Plus the node that we're currently on, right? So we need to account for that as well, I'm saying. So after we do that, guys, you know, if this value is bigger, right, it's gonna get updated, you know what I'm saying? So now the next thing that we do, guys, you know, to have the path, right? Remember I told you guys we choose between the left or the right, right? Plus root that value, I'm saying. And the other problem, right, we were doing in diameter boundary tree, right? We were doing max of, so we were getting the maximum depth, right? And we did +1, right, to account for the node, right, itself, right? But this time we do root that val, right, to account for the node's value, you know what I'm saying? So this is the same thing, guys, very similar. So pretty much what we do, guys, we go left, right? We go to the left, we get the answer from our left subtree, right? And we get the answer from our right subtree, right? We see which one is out of the two is bigger, right? And then we return that plus the node that we're currently on, I'm saying. And then the global max, guys, gets that special case that I'm saying when we add the value from the left, the right, what I'm saying, because we're considering a path like this, what I'm saying. It's like, you know, I told you guys that other thing that we did when instead of -10, we had -1, right? We consider that path, 9, -1, 20, 15, right? So this is what this case handles, what I'm saying. So yeah, guys. So let's go ahead and if we pass down these small test cases, guys, I'm saying perfect. Let's see if we pass all the test cases, guys. Perfect, guys. We're able to pass all the test cases, guys. Now I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this, and I'll see you guys in the next one.